Let's look at a word problem involving a quadratic equation where we hear the word maximum. This is in section 3.1. We'll see that a football is being kicked with an initial velocity of 128 feet per second. It's starting out at a height of 5 feet, and its height as a function of time is given by h of t is equal to negative 16t squared plus 128t plus 5. We'd like to know what the maximum height that the football reaches will be. A couple of things for us to notice here about the equation. First off, the plus 5 back at the back, that came from the initial height of 5 feet. Since it started off at 5 feet, we begin with a plus 5 at the end of our equation. The next thing for us to notice is that it is a quadratic equation. When you hear that word maximum, you're going to need a degree of 2 to be able to find that maximum value. Then the last thing I'd want us to notice is the negative sign out in front. This tells me that if we were to draw a picture of what's happening, it would look very much like the parabola that I've drawn here. It turns downward since we had that negative 16 leading coefficient attached to the square term. When you have a negative coefficient on that square term, it makes the parabola turn down. If you think about how it looks when a football gets kicked, this is the path that it takes. And what we're interested in knowing is that spot up at the top, that is the maximum height. Now, we were told the equation for us to begin with. Fortunately, we've got a little trick to help us find what the independent variable is going to be. Usually we call it x, but in this case, the letter t is our independent variable. You can figure out what the value of t is going to be by substituting in to negative b over 2a. Remember that b is the coefficient of our t term and that a is the coefficient of our square term. So as I substitute the things in, opposite of b, opposite of 128 is negative 128. That is to be divided by 2 times a, and my a was negative 16. 2 times negative 16, of course, is negative 32. Notice here that I have a negative on both top and bottom. This is important. Those two negatives end up giving me a positive result. Since t is representing time for us, we know that time needs to be a positive number. No matter how hard we try, we don't seem to be able to go back in time, so time is always a positive number. So the t value is going to be 4. But now let's think about the question. It said, what is the maximum height? If someone said to you, how tall are you? Would you say 4 seconds tall? No, we know that time was what we found, but now we still need to figure out what the height is going to be. So let's now take the 4 that we found and let's substitute it into our original equation that we started with everywhere we see a t. In for the t that was to be squared and in for the other t as well. 4, if you square it, makes 16. 128 times 4 is 512. When I multiply negative 16 times 16, I get negative 256. And if I add across this row, negative 256 plus 512 plus 5 more, turns out the maximum height was 261 feet. 3.1 is a little bit more challenging because it doesn't begin with an equation. We're going to have to generate our own equation. For this word problem, a carpenter is building a rectangular room that has a perimeter of 272 feet. We want to know what dimensions will give us the maximum area that is possible. Then we want to find out what that maximum area is. Now, I've underlined here some of the important words for us to notice. First, the room is rectangular. The second thing for us to notice is that we're told about the perimeter. We want to know the dimensions at the end. Area is going to be involved. And then last but not least, that word maximum shows up again. Remember, that word maximum tells us that we need a quadratic equation to be working with. We need something with a degree of 2. So now let's think about the things that we know. We were told about the perimeter of this room. Well, you've known since about 6th grade how to find perimeter for a rectangle. It's just P is equal to 2L plus 2W. We were given the perimeter. That was 272 feet. But you know what? When I get here, I notice a couple of problems. First thing I notice is that it's not quadratic, so I'm not going to be able to find a maximum from where I am. The next thing that I notice, I've got too many variables for me to be able to figure out anything. I can't do the problem when I have both an L and a W. So to help me get around that, let's see if we can solve for W. You could have solved for either of the two letters, but I think in the long run, W is going to be the smart one for us. As we solve for W, the first thing that we'll do is to move the 2L to the other side. Since it was a positive 2L on the right, when you move it to the left, it becomes negative. Now I need to divide everybody by 2 to get W to be by itself. Do you notice everybody there's got a common factor of 2? If we factored that 2 out of the top, it would cancel with the 2 on the bottom, and we would end up with W being equal to 136 minus L. Well, all that's great, but we still don't know what our dimensions are. What I need to think about now is how to create that quadratic equation involving area. You know how to do area for a rectangle. That's the length times the width. Since we know that W is the same as 136 minus L, anywhere that you see a W, you can replace it with 136 minus L. So up here, let's put in 136 minus L everywhere there was a W. Now this says L times 136 minus L. Look at the magic that's going to happen when we distribute here. L times 136 is 136L. L times negative L is negative L squared. There is that quadratic, that square term that we need. Now, just like before, we know a way to figure out what L is going to be. It's negative B over 2A. But be careful here because it's not in descending order of power like we're used to seeing it. B is the coefficient of the L term, and A is the coefficient of the square term. So opposite of 136, that's going to be negative 136. 2 times A, this is an understood negative 1, so 2 times negative 1 gives me negative 2. Again, notice the two negatives. When we do this division, we end up with a positive 68 for the length. You couldn't have had a negative length, could you? So 68 is the length of this. But we were asked for both of the dimensions. If you take 68, you put it back in for L there, 136 minus 68 looks like W is also going to be 68. What kind of a rectangle has the length and the width the same as each other? That's a square. Maximum values come when we have square terms and square shapes. So 68 was the length and the width. Now, to figure out what the maximum area actually is, all you've got to do is the length times the width. If we do 68 times 68, the maximum area that we'll get is 4,624 square units.